In the previous video, we have discussed about the instruction fetching and execution phases, the single bus organization of the data path inside a processor, the individual block and their functioning. Today, we'll discuss about the register transfer. So we know whenever this program is getting executed, so number of steps are involved where the data has to be transferred from one register to another register. So this register, it acts as a temporary storage where it has to store the data from the bus, or it has to send on the bus. It has to send the data on the bus. So whenever we are using this register to hold the data or to send the data on the bus, we'll say that it will be using two control lines. One is RI in and the other one is RI out. So we'll use two control signals which are RI in and RI out. If RI in is equal to 1, if RI in is equal to 1, the data on the bus are loaded into RI. That is, we will be using two control signals RI in and RI out, which are to say about the status of the data present in the register. If RI in is equal to 1, the data on the bus are loaded into RI. If RI out is equal to 1, the contents of the register RI are placed on the bus. So if RI in is 1, the data on the bus are loaded into RI. If RI out is 1, the contents of RI are placed on the bus. So this is how these two control lines will be used to say about the status of the data which are present in the register. So we'll take an example where we are trying to send the information which is present in R1 to R4. We have taken two registers R1 and R4. We are trying to send this data from R1 to R4. So now whenever you are saying from R1, then the output of R1 should be enabled. That is, if the first condition is you have to set R1 out is equal to 1. Therefore, the content which is present in R1 are ready to send on the bus. Next one is R4. We have to send to R4, right? So R4 should be set, that is input should be set to 1 so that it can receive the data. Therefore, when you are using the two registers R1 and R4 and you are trying to send the data from R1 to R4, the first step is to activate R1 out is equal to 1. Right. So when this is done, so this is to say that the content of your register R1 are placed on the bus. The second step is you have to activate the input of R4. Therefore, you have to say R4 in is equal to 1, which is to say that the data on the bus are loaded into R4. So these are the two steps which are involved when you are transferring the information from R1 to R4. Just now I said, so how this R1 or R1 in or R1 out we have used to say about the status of your information. So this is the block diagram we have where we have shown the input and output gating for the register. So you can see here every register RI is connected to the bus. Right. So every register or the register whatever we are using RI, it is connected to the bus with the help of the switches. So these switches will be having two control signal. One is R1 in, RI in, and the other one is RI out. So already said, when RI in is equal to 1, it is to say that the data on the bus are loaded into RI. When RI out is equal to 1, the content of register RI will be placed on the data bus. So based on this setting of the value, we can make sure that whether we have to load the data from the bus on the register or we have to send the data from register to on the bus. So now you can see here similarly we have the register Y in what we have. So register Y we have. So it is connected to the bus with the help of a switch with the control line Y in. So with the help of control line Y in. So this output Y is given one of the input as a mux, where it can be used as an operand, one of the operand for ALU. So you can see here this mux, we know that it will be working based on the select line we are giving. So this output of the mux is connected to one of the operand of your ALU. So here you can see that this Y is fed to the mux. This is one of the input of the mux, and we have taken 4 to say that this program counter has to increment by 4, because in the 32-bit processing we have seen that the memory addresses will be keep on increasing in the function of 4, right? So 0, 4, 8, 12, 16, it will keep on going. So this y is put as input one of the input as for mux, and this mux output is taken as the input for the ALU, that is one of the input is A, and the second input what we have B, it will be taken from your directly bus. So similarly you can see here the register what we have Z. So this Z is also having two control signal, one is Z in, Zi in, and the other one is Zi out. So this section, so Zi out we have. So based on the status of your the value what we have given, that is like whether we have to store the data from bus to register or from register on the bus, you can give the value and you can select the status. So this is the example we have taken where we are trying to implement the 1 bit of register RI. So you can see here we have used the flip-flop and we have used a mux, right? We have used a mux and we have used a flip-flop too, and RI in and RI out also used. So here when this control line RI in is equal to 1, that is if RI in is equal to 1, then the multiplexer will select the data on the bus. You can see here RIN is equal to 1, then the multiplexer will select the data on the bus. So this data will be loaded into the flip-flop at the rising edge of the clock. If this RIN is equal to 0, if this RIN is equal to 0, then the multiplexer feedbacks the value which is currently stored in the flip-flop. So this is, you have the signal RIN. If this is 1, the data will be taken from the bus. If it is 0, the multiplexer will feed back the value which is currently stored in the flip-flop. So now you can see here we have the output Q. We have the output Q. Which is connected to the bus, via tri-state gate. So now you can have tri-state is nothing but 0, 1, or you can even have high impedance state. That is what tri-state we have. So if R1 Ri out is equal to 0, so the gate's output is in high impedance state. That's now just now I said you can have 0, 1 or high impedance state. So if Ri out is equal to 0, the gate's output is in high impedance state, which acts as a open circuit. If Ri out is equal to 1, the gate drives the bus to 0 or 1. If Ri out is equal to 1, the gate drives the bus to 0 or 1 depending on the value of Q. So now let's take an example where we are trying to add the content of register R1 with content of register R2 and store the result in R3. The content of R1 are added with content of R2 and the result is stored in R3. So we have written the sequence of steps over here. So in the first step we are trying to take the data present in R1 and it is loaded to the temporary register Y. So to make this done, that is R1 and Y we have taken, the content of R1 we are trying to send to the temporary register Y. Therefore the output of R1 has to be enabled and input of Y has to be enabled, right? We are trying to send the data present in R1 to Y. Therefore R1 out has to be enabled and Y input has to be enabled. That is what we have written in the first instruction, R1 out comma Y in. So in the previous diagram we have taken that, we have seen, so in the ALU part we have shown you that one of the operand is taken as A and the other is B. For this A, the output we have taken it from mux, and for this mux one of the input we have taken is Y, right? So now what we are doing, so this Y is fed to the input A. Next is we have to take the second input. The second input is B. So here the second input is present in R2, right? The second input is present in R2. Now you have to activate output of R2. You have to activate output of R2. You have to select Y. So this will act as A and this will act as B. Add it. You have to add and store that result in one more temporary register Z in. Right, so you took R2 out, so that acts as your input B. Now you have taken select Y, which acts as your input A. Add A plus B, nothing but R1 plus R2, and store the result in a temporary register, which we take it as Z in. But ultimately we have said that the result has to be stored in the register R3. Therefore, from Z in you want to send this data to R3. So at Z in you have to make this Z into Z out and R3 in, right? So previously it was stored in Z in. So in the next step you make the content present in Z2, you have to send it to R3. That's why Z out and R3 in. So this is how we can activate the signals based on the conditions, like whether we are trying to input or we are trying to output. If you are trying to send the data from one location, that is from R1 to, if you wanted to send it to Y, what we did, we activated the output of R1 and input of Y. If it was from Z to R3, that is result, what we did, the output of Z and input of R3, they are activated. So based on this we can write the sequence of steps how you can perform the operation.